Hello and welcome to our channel. In our last video, we talked about the big picture of AI and data in our field. Today, we get practical. We are going to write your first Python script for chemical engineers. You might think coding is complex, but I am going to show you how in just few minutes we can use Python to automate a fundamental calculation that every single one of us has done by hand, the Reynolds number. Before we write any code, let's quickly review the concept. The Reynolds number is a crucial dimensionless quantity that helps us predict the fluid flow behavior in a pipe. The formula is Re equals rho times V times D all divided by mu, where rho is the fluid density, V is the velocity, D is the pipe diameter and mu is the dynamic viscosity. As you can see here, the value of the Reynolds number tells us what kind of flow we have. A low Reynolds number, typically less than 2300, indicates smooth, predictable laminar flow. A high Reynolds number greater than 4000 indicates chaotic, mixing, turbulent flow. In between those values, we have the unpredictable transition flow. Understanding this is key for everything from designing pipeline to predicting heat transfer. Now let's make the computer do the work for us. Here we are in the Thonny IDE. We can see the computer Python script that calculates the Reynolds number. Here we are defining the function. The function name is Reynolds number. Here is the input: density, velocity, diameter and viscosity. We already know that Reynolds number is rho v d by mu. So here we are writing one line code. So Re is equal to density, velocity, diameter divided by viscosity. When that function gets that all this value, density, velocity, diameter, it will calculate the Reynolds number and return that value. Now here we are going to calculate the Reynolds number. So for that, here we are taking density is 1000, obviously kg per meter cube. Here I am taking as a water density, then velocity 2.5, diameter 0.1 and viscosity 0.001. Now here result is Reynolds number, the bracket density, velocity, diameter and viscosity. Means here in the result is equal to, we are calling the function the Reynolds number. So this is the function name and then here we are giving the input. So when we are giving the input, that will calculate the result. So now we are going to print that result. So print Reynolds number. So that Reynolds number will coming out in the output, and result will be, if I do the calculation, means that computer will do the calculation and that will give the result 25000 this. And here I am putting that print statement, print flow type, that is turbulent, Re greater than 4000. So now if I run that, you can see here, first stop that and then if I run, you'll see that result is coming out, Reynolds number 2540.0 and flow type turbulent, Re greater than 4000. Obviously here I can put bracket, so it will show nicely. Okay, 4000. Next video I'll give one more complicated Reynolds number calculation. And just like that, you have seen how a few lines of the code can automate a fundamental chemical engineering calculation. This is the first step towards data analysis and AI. If you are finding that content valuable and want to continue on this learning path, please take a moment to hit the subscribe button. It helps the channel immensely and ensure you won't miss what coming next. Thanks for watching.